In the stacked blocks on a smooth surface problem, there are two blocks stacked one on top of the other, with the top block having a mass of 3 kilograms and the bottom block having a mass of 5 kilograms. The surface between the two is not frictionless, so there is a static friction coefficient of 0.4. The problem wants us to find the maximum force that could be applied to the bottom block before the top block begins to slip off. So we have a picture right here of the force being applied to the bottom block with the top block on top of it. And what we can do first is we can draw, since there's two objects, we can draw two free body diagrams. So the free body diagram for mass 1 will look something like this. And the forces acting on it are, here's the center. The forces acting on it are the normal force pointing up, Fn, and force of gravity going down, Fg. And then there's the force being applied, so we'll call that Fa. And then there's this line is very straight, but there's the force of friction from the frictionless, or the surface having friction, call that Fs for the static friction. And then for the second mass, M2, we have the force of gravity pulling down on it, Fg, and there's also the normal force going on it, and there is the force applied. And the force of there's no friction force on the bottom block, it's only on the top block. So essentially the formula that we want to use is Fs max is equal to mu s times the normal force. And we want to set it equal to it because that's the maximum value that it can be at. Not if it was a less than sign, it would still be, the top block would still stay on. But since we're setting it equal to, that's the maximum value, and if it was a greater than, the top block would slide off. So the normal force, or since the blocks are just moving horizontally, that means that the normal force is going to be the same as the force of gravity. But since there are two blocks, one on top of the other, the force of gravity will be 3.0 plus 5.0 times 9.81. So you have to add up the two masses, and that will give us 78.48 newtons of force. So now we can set up the equation to where Fs max equal to use of us, which is 0.4 times the normal force on the two blocks, which is 78.48. That will give us approximately 31.4 newtons. So if more than 31.4 newtons is applied to a force is applied to the bottom block, then the top block will begin to slip out. In order to check this problem, we can simply plug in the force that we got, which is supposed to be the maximum force, into the equation, and then we can solve for, or take 0.4 out and put in mu sub s to make sure that the force still gives us 0.4, which is the coefficient of static friction, which is a constant. So we do 31.4 equal to mu sub s times 78.48, which is the normal force. We're going to want to divide both sides by 78.48. So we get E sub S is equal to 0.4. So it's still the same. But if we increase the force to, let's say, 33 newtons, the answer would be 0.42. So that's over the coefficient of static friction. So that means that the static friction force has been exceeded. So the box on top is going to begin to slide off.